All right, today we are doing the worst day of the semester for you guys because we introduced 4 convergence tests. We've got one more to do, but that one is so obvious when you see it. Like you'll know it to use that test. And so this is where you get the entire toolbox and you're like, which fucking tool do I use? But before we get started on 9.5, Dalton asked me a question at the end of the last class after everyone had left. And he said, why the fuck do we need to bother on improper integrals, swapping out the infinity for like a letter, like limit as n goes to infinity and then doing 1 to n. And I said, like, I told him that like pure mathematicians have been doing it, but like when I'm doing it on my own, I don't. And that's true. If I'm solving something that I don't need to get someone else, I don't bother doing it. With further thought, it may or may not be important when you're doing Calc 3 and doing double and triple integrals. Because at some point you're going to have x, y, and z in there. And sometimes you'll have y as a function of x and x as a function of z. And you might need to wait till everything's done being integrated. And keeping track of the letters of change value. It may fuck it up there. As I said, if it's on the test, do the letter substitution. If you're doing it on the homework, I'm not going to check, but if you practice doing it with the right way, with the putting the letter in, you're better off that way, but it really doesn't change anything for the most part. I don't bother with it when I'm solving, like when I'm making my answer key that I'm not going to post for you guys. I don't do it unless it was like this last test. This last test, I made sure I did it. That way I made sure to check that you guys were doing it. All right, so today we've got 4 tests for you. The comparison test, the limit comparison test, which I think is the easier one of the two. And that pin's dying, so I'm going to grab another black one. The ratio test and the root test. So let's just dive right in. Let's start with the comparison test. We're gonna let the summation of a sub k and b sub k be series. With positive terms, all positive terms. And a sub k is less than b sub k for k greater than some n. The first few can be in a different order, but eventually a sub k needs to be less than b sub k for the entire rest of the series. So we have 2 things going on. We're gonna compare them. If the summation of b sub k converges, then the summation of a sub k converges. So we like have the sum of b sub k. If it converges, it has some value. And if the summation of a sub k is less than it, then it also doesn't go to infinity and it must converge. So kind of like a way to remember this is if a series converges, any smaller series converges also. And we'll call that part A, part one. I was gonna say A, but we got A and B here. Part two. If A sub K diverges, then so does B sub K. The idea here is we have some sum of A sub K, but if it's diverging, it's going to infinity. And if the sum B sub K is larger than it, then it's also got to be larger, going to infinity. And a way to remember this one is if a series diverges, any larger series diverges also. This is very, very particular. Those two are, those are the ones that matter. B sub, if you do A before B, A is less than B, you remember that order. B has to converge, A has to diverge for these things. If you try to mix and match that, look what happens. These don't work for comparisons. If the summation of B sub K diverges or equals infinity, and A sub K is less than it, well, that has two outcomes. It could be divergent also, but, or it could also just equal some limit. It could converge, and that limit would be less than infinity also. So B sub K diverging doesn't tell you shit about A sub K. Says jack shit about A sub K. And then if the alternative to this one, the other one that doesn't work, summation of A sub K could converge. Let's say it equals L1. And we know B sub K is greater than it. Well, B sub K could go to a limit like L2, maybe even the same limit, or it could go to infinity. So we have convergent or divergent. And what I wrote up here was B sub K diverges says jack shit about A sub K, but I could just define that as any smaller series. And I could say the same thing here about A sub K. A sub K converging says nothing about larger series. Write that down, and we'll do some examples. You are gonna start with one series. That's what you're gonna start with. So you are picking another series to compare it to. And so you want to pick one that you know how to work with. What do we have right now that we know how to work with? We know how to work with P-series tests. We could do a geometric test if we see that. That kind of like does it. Harmonic series is in the P-series. It's a P equals 1. Sometimes you just pick one that isn't like that, but you could show it's divergent using the divergence test. But it has to fall under it being the smaller one. And so you need to like check that assumption before you even start. Give you another minute and we'll start doing some examples. I got a fistful. We got a bunch for every category. We got one that took me like fucking 30 minutes today to figure out how the hell to do it. I'm going through test after test after test, and finally I ended up doing a U sub, and the U sub helped me. That's the last one we're gonna do. All right, so first example. We will have the summation of n equals 1 to infinity of n squared over n cubed plus 1. So sometimes looking at the largest terms on top and bottom and using those as what you compare to will help. But let's see. How does this compare maybe to n squared over n cubed, which would be 1 over n and harmonic, and we can deal with. We know that one. But like, so let's say n equals 10. I have 100 over 1,001. And how does that compare to 100 over just 1,000? If the number is, if the denominator is bigger denominator with an equal numerator, I don't know what word just came out of my mouth, but it was not numerator. Bigger denominator, same numerator, smaller fraction. And vice versa. Smaller denominator will lead to a bigger fraction. And so like bigger denominator, this one is bigger, which means it's smaller than this one. And this one being divergent is in that doesn't help me case. This one can diverge and this one can converge still. So this is not helpful. This was an unhelpful choice. But you have to check them because like doing the easiest one to check, this one's easy. We know right away what the answer is. You got to see if it meets the criteria you're looking for. That should say unhelpful, but it said you helpful. What about, so when you have something like that, then maybe consider changing. I chopped off the 1. Now let's change the 1 into something that is useful to us. Let's compare it to n squared over n cubed plus n cubed. And I deliberately picked n cubed because I can add them together. That would be n squared over 2n cubed. And if I do n equals 10 here, I've got 100 over 2,000. And that's going to be smaller than our 100 over 1,001. And so if this diverges, then this one does also. Does that make sense? So I replaced the one with something that was equal so that I could add it together and make it something that's useful, because I can take n squared. Where'd my blue pen go? Rude. I can look at the limit as n goes to infinity of n squared over 2n cubed. I can pull out that 1/2. And I'm looking at the sum here. Well, no, either way. Yeah, I got the sum here. Let's do the sum here. Sum equals n equals 1 to infinity. This ends up being 1/2 the sum of n equals 1 to infinity of n squared over n cubed. And since n is not 0, we can clean that up and it becomes 1 over n. This one is harmonic and diverges. And because the sum is n equals 1 to infinity of n squared over 2n cubed is less than or equal to, the sum is n equals 1 to infinity of n squared over n cubed plus 1, then this one diverges also.
Wait, isn't it great? Oh, wait, never mind. I got those backwards. You broke through.
Because since this one diverged, this one's sum is eventually going to be infinite if you take n far enough. You don't know which one you're starting with until you're going through with it. In this case, ours is the b sub k. And that's our a sub k. But you got to try to compare things and see how it compares. And you won't know if it's convergent. If you know it's convergent or divergent right away, it's helpful. Like the one you're comparing it to. In fact, usually that's where you'll use the comparison test. If you don't know what, have any idea what the limit is, what you're comparing to, what's the point in doing it? Comparing to an unknown limit doesn't help.
So it's bigger or smaller.
And yeah, and then it's gonna either, but it's gotta meet the criteria we had last time. If you're going for diverging, you need to be, the b sub k is what you started with, and you're showing a sub k diverges, and b sub k is larger than it. And if you're going for, which is this case right here. Does that make sense? Sometimes just looking at the first two can give you an intuition. Like, look at the leading terms. Which is what I started with. The n squared and the n cubed. doing something around this. Because this is 1/n and that diverges. So your initial thought, maybe if you just looked at the leading ones, which is a good way to do it, look at the leading ones and go, what's going on? If there is a leading one, like polynomials or something like that. Look at the leading terms on top and bottom. When I mean leading terms, the largest exponent on top and bottom. Look at them, go, what does that look like? Like if I had n squared over n to the fourth, this would be 1/n squared, and that looks like it's converging. So maybe find a way to compare it to something that is converging that we can show we're smaller than. Does that make sense? Is everyone with me on that? Kinda. It takes some practice. I got a couple more that we're gonna look at, so maybe like seeing more model. So let's take a look at the sum of n equals 1 to infinity. 8n over 2n cubed plus 4n squared plus 5. I probably should have done it on the last one, and I didn't because I knew we were going to go into the comparison test. But divergence test is always really quick and worth doing. I can take the 8n over 2n cubed plus 4n squared plus 5 and multiply top and bottom by the largest exponent on the bottom. Multiply top and bottom by 1/n cubed. This would get me 8/n squared on top. This gets me 2 plus 4/n plus 5/n cubed on bottom. And if you hit that with the limit, you can see quickly this is going to 0/2, which is 0. And divergence test doesn't tell us anything if it goes to 0. So the divergence test isn't helpful, but a lot of times you can do that by inspection. With practice, you'll get to the point where you'll recognize the top is smaller than the bottom, so this is going to go to 0. Right? So now, like the divergence test didn't help here, so what I'm going to do is I'm going to look at the first two terms. The first term on top and bottom. 8n over 2n cubed. If I simplify that, I get 4/n squared. That would be a p series. P equals 2, which is greater than 1, which would be convergent. I'm thinking this is going to converge. So I am going to shoot for convergence. Does that reasoning make sense? If you've been doing that homework, did the p-series homework, stuff like that, it will make more sense. If you haven't done any, like touch that section, this is a little bit harder because you're like, huh, I didn't do it. But I can't make you do your homework. So if I want convergence, and if it helps, write down like this notation here and just think about what's got to happen. I want to be this one, make mine this one, and find something that works here. So I want something that's larger, because if the larger thing converges, then the smaller thing converges. All right, so what can I compare it to that's larger? Can I compare it to the 8n over 2n cubed? That would be fantastic. How does 8n over 2n cubed plus 4n squared plus 5. How does that compare to 8n over 2n cubed? This bottom is larger than this one, which means than that one, which means this one should be smaller than that one. Larger bottom equals smaller top or smaller overall, which means that's what we wanted. So this is perfect. We'll compare to this. So we've got n equals 1 to infinity. And we know our sum, I'm gonna just call that a sub k, so that I don't have to write the whole fraction. 1 to infinity of a sub k is less than 8n over 2n cubed, which is the sum of 4 over n squared, which is a p series equal to 2, p equals 2, thus convergent. And that means my sum of a sub k converges also. This is what most of your test is going to be. Does this series converge or diverge? And I'm being merciful because I think 9.7 through 9.10 is an entirely unrelated topic. So they're going to be different tests. Poor Ainsley, she had to back and do series along with fucking Taylor series. There's our connection. They're both series. But like Taylor series and other shit feels more applicable than this bullshit. Not a big fan of this, most of this chapter. 9.7 on is the fucking golden goose. But if you don't really understand these, like some of this, Taylor series and Maclaurin series mean jack shit. All right, you guys ready for another? Anybody need that longer? All right. Let's take a look at summation of n equals 1 to infinity of 1 over n factorial. And I'm going to give you a hint because you probably don't know this. 1 over n factorial is greater than 2 to the n minus 1 for large n. There's other things we'll do with factorials, but we haven't hit that yet, so. So if this is true, what is the relationship between 1 over n factorial and 1 over 2 to the n minus 1? It'd be less than. If you do the reciprocal, flip the inequality. And if you don't believe me, start with that and divide both sides by n factorial 2 to the n minus 1. And you will get 1 over 2 to the n minus 1 is greater than 1 over n factorial. So since this is less than, since we're doing less than here, I guess that's small enough. I don't need to write a sub k. 1 over n factorial is less than n equals 1 to infinity of 1 over 2 to the n minus 1. Well, It's kind of looks geometric, but it's not in the right form of geometric. There's a couple ways about going about doing this. Wait, I didn't put the inequality sign in there. Fucking looks stupid without it. We can either change our limits. Or do some fancy, like not really fancy, but do some manipulation. So if I wanted to change my limits, I could say like k equals n minus 1. And that means n equals 1 is going to turn into k equals 0. And this is rewritten as k equals 0 to infinity of 1 over 2 to the k. That's probably the easiest way to do it. And with practice, it gets a lot, you get used to doing it. And we know this one is geometric because I can rewrite that as 1 over 2 to the k. Geometric converges. Which means our summation of n equals 1 to infinity of 1 over n factorial also converges. Notice I didn't show what the sum was. Geometric series, you can actually find what the value is. And maybe we should, just as good practice. What does this equal? Geometric series is in the form of AR to the k equals 0 to infinity. We get a over 1 minus r. Well, a here looks like a 1. 1 over 1 minus 1/2 is 2. So this one converges to 2. That doesn't tell me this one converges to 2. We just know it converges. It's less than 2. It probably doesn't even go to 1. You got to think how fast n factorial gets large. 5 factorial is what, 120 on bottom? 5 factorial, 1 over 120. 6 factorial would be 720. 1 over 720, you're getting small really fast. But it converges.
So it's 20.
All right, let's take a look at the limit comparison test. It's just a crappy handwriting for comparison. So crappy that I'm rewriting it. And hopefully I don't fuck it up again. So we're gonna stick with the whole let sum of a sub k and b sub k be series. And we're gonna let L equal the limit as n goes to infinity. A sub n over b sub n. If L exists, and L does not equal 0. Then they either both converge or both diverge. And my pro tip on this one is, again, look at the leading coefficients. This is good for polynomials. Not leading coefficients, but leading terms on top and bottom. And let the B sub k be the P series of those terms. So let's look at an example. Now we're going to do 2 of the 3 examples we just did, and then maybe some other ones. We will start with summation of n equals 1 to infinity of n squared over n cubed plus 1. So if I look at n squared over n cubed, that's the same as 1 over n. So we're going to look at a sub n over b sub n. This is my a sub n. That's my b sub n. N squared over n cubed plus 1 divided by 1 over n. Because we're going to do this right here. Limit as n goes to infinity of that. Multiply top and bottom by n. And we are looking at the limit as n goes to infinity of n cubed over n cubed plus 1. The bottom becomes 1 and we don't have the complex fraction anymore. Here, multiply top and bottom by 1 over n cubed. Limit as n goes to infinity of 1 over 1 plus 1 over n cubed. As this goes to infinity, this goes to 0, and we get 1 over 1, which is 1, and that's my L. L exists. L doesn't equal 0. So that either both converge or both diverge. So this means both converge or diverge. B sub n was the sum of 1 over n. That's harmonic and diverges. Which means what we started with diverges. Thus, A sub n diverges. With the A sub n labeled right there. And we showed it diverged in just a little bit ago doing the comparison test. I think this test is a little bit easier to do than the fucking comparison test. Comparison test, you gotta compare it, make sure it's right. Here, they converge together or diverge together. Either you go down with the ship and everyone goes down with it, or you make it to port. Not too bad. Just go with the leading terms, compare that way. Everyone ready for another? You already know what the other is because I said it was one of the other ones we did. And this doesn't look like it's going to be great for factorials. So n equals 1 to infinity of 8n over 2n cubed plus 4n squared plus 5. That's my A sub n. B sub n, look at the leading terms, and you don't really need to worry about the coefficients. The largest term on top is n, the largest term on bottom is n cubed. So we're going to use Bn equals 1 over n squared. And that's going to be the bottom of our superfraction. So multiply top and bottom by the reciprocal of the bottom. N squared, n squared. We're going to do the limit as n goes to infinity of 8n cubed. Just multiplying the tops. This whole bottom is going to cancel. And our 2n cubed plus 4n doesn't change. And we'll multiply by 1 over the largest term on bottom. Multiply top and bottom by 1 over n cubed. So what's the limit here? Limits 4. Bottoms of these go to infinity, which means those fractions go to 0. We're left with 8/2, which is 4. So L equals 4. Does not equal 0, and it exists. So they both converge or diverge together. B sub n was 1/n². That is a p equals 2 series. And when p is greater than 1, it converges. So this converges by the limit comparison test. I'll say that sum of a sub n converges by limit comparison test. Now at this point, you're going to want to start adding in when you're doing it, get in the practice of adding in by which test you're finding convergence or divergence, because you'll need to show that on the test. And don't assume I'll figure it out, because you will probably try on some of the problems a bunch of different tests before you settle on the one that works for you. And some of you like are all over the fucking place. I'm sure Dat's gonna write fucking 8 different things down, cross them out, and I get to pick which one it is. If you circle it and tell me which test you use by name.
Also, it means, trust me.
I know. But it doesn't make it like it's not an obvious cross out. He'll be like the whole page like this. And he'll have a single line through it, not even an X, just a single line through it, not thick like the pen, but thin like the fucking ink. That's his way of saying ignore all that work. Not fucking like scribble it out, not like a couple big
He's on a
X's,
time crunch.
right?
He's only got 2 hours.
But it could have just as easily been, I got distracted and fucking did a stray mark on the paper. Yeah.
Really not a question. I think you did say something about it today. You have the exams.
Yeah, and when on break one about. No one reminded me, but I remembered on my own. I'm so proud of myself over that. It's fucking embarrassing.
I'm really glad you did, because I forgot.
Right now, I'm grading the CSI 1 exams online. Aaron's in the class. I don't know if anyone else in here is in the class. Someone submitted an exam with the wrong fucking name at the top. As a comment, has Jenny Rain as the name, and there's no Jenny in my class. I'm like, really? I don't care if you copied it and changed it to match what you liked. You still based it off someone else's code and just made edits. 0. All right. So let's do, I'm tired of writing it, summation of n equals 1 to infinity, but we have to. We're doing square root of n over n squared plus 1. This might be a little bit easier if I rewrite that as n to the 1/2 over n squared plus 1. Divergence test will show 0. So inconclusive. But if you write that as n to the 1/2 over n squared, we can make that our a sub n and pick b sub n to be the first term or leading term on top and bottom. That is going to reduce to 1 over n to the 3/2. Okay, so if we do this as limit as n goes to infinity. A sub n over b sub n. I've got limit as n goes to infinity. Of n to the 1/2 over n squared plus 1. And b sub n is 1 over n to the 3/2. Multiply top and bottom here by n to the 3/2. So we get the limit as n goes to infinity. These cancel. N to the 1/2 times n to the 3/2 is n squared on top. We multiply. I've been multiplying by 1 over the largest term on bottom. There's another way of thinking about that. That's the same as factoring out an n squared on bottom, top and bottom. And then canceling them. Does that, you guys see that? Factor out the n squared. It might be harder to factor out, but if you're good at factoring, it's not a big deal. So we either factor out the largest term from top and bottom, or largest term from the bottom. Or multiply by the reciprocal. Either way, we get the limit as n goes to infinity. Of 1 over 1 plus 1 n squared. N squared goes to infinity, so this goes to 0. And our limit equals 1. Which does not equal 0, so they converge or diverge together. B sub n was 1 over n to the 3/2. This is a p series. P equals 3/2. I made that look like, God, let's try this again. P equals 3/2, which is greater than 1, so it's convergent. The summation of n equals 1 to infinity, squared n over n squared plus 1, converges by the limit comparison test. I've been doing A sub n as our starting one. But it can be B sub n if it works easier. Let's take a 10-minute break. If you want your test back, come on up, give me your last name. All right, let's give you a shitty one. Let's do some of Oh, I didn't write down the starting value, so I'm gonna just go with K equals 0. 5/2 times 3 to the K. Plus 1. Now, the divergence test, you do the limit as it goes to infinity, this is gonna equal 0. That doesn't tell you whether it converges or diverges. What does this kind of look like here, though? Like what? It looks kind of like a geometric. So maybe we can compare it to like 1/3 to the K. Now here, if I put 1/3 to the K on the bottom, I think it's gonna be a little harder to clean up. So I'm actually gonna put 1/3 to the K on the top. Do the limit as n goes, or K goes to infinity, because I've got K here. 1/3 to the K divided by 5/2 times 3 to the K plus 1. And it makes the work here a little bit more difficult at this step, but we can actually do it. We're multiplying the top and bottom by the reciprocal of the bottom. And we get the limit as K goes to infinity. 2 times 3 to the K plus 1 over 5 times 3 to the K. I guess we could have done it the other way. Yeah, it would have worked just fine the other way. I had in my hand that had to split this into 2 fractions, but that isn't that necessary. 3 to the K is not 0, which means we can multiply top and bottom by 1/3 to the K at this point. And we're gonna get limit as K goes to infinity. 2 plus 1/3 to the K all over 5. Remember, you got to distribute. It's got to hit each term. As K goes to infinity, 3 to the K goes to infinity, and this goes to 0. And the limit is 2/5, which does not equal 0, so they both converge or diverge. And 1/3 to the K was a geometric series, which definitely converges. Geometric series, this is 1/3. R equals 1/3 is less than 1. It's in that requirement. We need the absolute value of R to be less than 1. So it converges. So K equals 0 to infinity of 5/2 times 3 to the K plus 1 converges by the limit comparison test. And now the glorious final 2 tests of this section. We will do the alternating series test next week, but that one has a -1 to the n power in it, and you will fucking spot that thing like a fucking zit that's right in the middle of your fucking nose. So we've got the ratio test and the root test. And they follow similar enough rules that we teach them together. So let the summation of A sub n be a series with positive terms. This next step has two different ways we're going to look at it. So for the ratio test, we let the limit as n goes to infinity of A sub n plus 1 over A sub n. Or that's what we're checking. Does this equal L? It will equal something, but like it may be an infinite. And the root test is limit as n goes to infinity of the nth root of A sub n equals L. So if L is less than 1, then the summation of A sub n converges. If L is greater than 1, then the summation of A sub n diverges. And if L equals 1, you cry in extreme disappointment because it's inconclusive. Which means you're going to have to try something else. And remember, if you watch the video on 9.2 on the monotonic series, we did like a ratio test with monotonic series, and it follows the same idea. If it's going down in value but stays positive, it's got to converge. It's something like that. Ratio test, great for factorials. And it can even be good for exponential problems where the variable is in the exponent. The root test is really only good for exponentials. Because the nth root will factor or cancel out the nth power, and you're not dealing with the shitty fucking exponent anymore. I wrote exponents. Exponentials is a better way to say it. Polynomials have exponents. Exponentials has the fucking variable in the exponent. Jeez, that looks like shit. Exponential. Yeah. Yeah. Sometimes one is better than the other. And we'll do some examples and you'll kind of like get a feel for it. Ratio test tends to be great when like you've got a fraction and one side has an exponential, but the other doesn't. Because the idea is that the root test here, you want it to cancel out the exponent and not have anything else there. Because having the nth root of anything is also fucking garbage, not fucking helpful. So you want the root test to cancel out the shit. And not leave any shit of its own left over. You don't want to be left with a root in there. Everyone ready for some examples? All right. Let's start with n equals 1 to infinity. Of 4 to the nth power over n squared. So if I do a root test here, I'm taking the nth root. This will help with 4 to the n, but not n squared. So fuck that test. The nth root of n squared, what the fuck do we do with that? That's not helpful. So let's give the ratio test a try. So what we're going to do is we're going to do limit as n goes to infinity. On the top, we will do everywhere there's an n, we will replace n with n plus 1. So this is like a sub n plus 1 on top. And on the bottom, we will do the original. That's my a sub n. Complex fractions, we don't like them. We're going to multiply by the reciprocal. So I will have limit as n goes to infinity. I've got 4n plus 1 over n plus 1 squared times n squared over 4n. Now, first thought may be, how does that fucking help? The exponential is actually going to be really helpful. What we're going to do is we're going to write that as 4 times 4 to the n. And I will multiply this bottom out. Which fucking bad potential fraud this time. That's even better. Normally it says scam call. So I just expanded the top and the bottom. And now the 4 to the n's will cancel, leaving behind a 1. And I can multiply top and bottom by 1 over n squared. And I will get the limit as n goes to infinity we'll just have 4 on top. That one right there. And down here, we've got 1 plus 2 over n plus 1 over n squared. As n goes to infinity, that goes to infinity, that goes to infinity, means that fraction and that fraction go to 0. I have 4 is my limit. And in that case, 4 is greater than 1. If L is greater than 1, it diverges. N equals 1 to infinity of 4 to the n over n squared diverges by the ratio test. N equals 1 to infinity of 1 over n factorial. We did that earlier by comparing it to 2 to the n minus 1, but here, now we're going to use the ratio test. So if I do the ratio test here, I have a limit as n goes to infinity. The top, I'm replacing n with n plus 1. And the bottom is just going to be the original. I will multiply top and bottom by n factorial. And I'm going to get the limit as n goes to infinity. The top is n factorial. I'm not going to write n plus 1 factorial. I'm going to strip off the n plus 1 term. This is n plus 1 times n factorial. This does equal n plus 1 factorial. But that's why the ratio test works here, because it cancels out the factorial part. You basically, with the ratio test and the root test, is you want the bullshit to go away. And the bullshit is the factorial or the exponent having the n. We're left with limit as n goes to infinity of 1 over n plus 1, which is 0. That's my L here. L is less than 1, so this is convergent. N equals 1 to infinity of 1 over n factorial converges by the ratio test. So this is the ratio test is pretty good. Like it showed divergence here. It showed convergence here. The only time it's not helpful is when L equals 1. And we will have one of those later, I think. All right, root test. At some examples of root tests. This one has to start at 2 because we are going to have n plus 1 over n squared minus 1, all of that shit to the n. So like if we tried the ratio test here, we got to put n plus 1 there, we got to put n plus 1 there, and n plus 1 there. You don't want that. Like we had it help us with 4 to the n up here. But when we got an n inside the exponent, or like the exponent is applied to another variable, that's no bueno. Ratio test is just going to create more bullshit. That's how I like this thing. Get rid of the bullshit. So root test, we got the exponent, try the root test. We will do the limit as n goes to infinity of the nth root of what we had. Which equals the limit as n goes to infinity of n plus 1 over n squared minus 1. There's a couple ways you could do this. We could do 1 over n squared. Works here, or factor. And we get limit as n goes to infinity of 1 over n minus 1, which equals 0. So L equals 0, less than 1, convergent. N equals 2 to infinity of n plus 1 over n squared minus 1 to the n is convergent by the root test. That was fun. So having noticed this, I'm going to go back and I'm going to change what I said about the root test. We said the root test was good for exponentials. Exponentials on variables is better. This is where its bread and butter is. Like the ratio test isn't good for this scenario, but when you got an n to an n or an x to an x, or some bullshit like that. Ready for some more fun? N equals 1 to infinity of 1 over n to the n. Go ahead and do that real quick. Try the root test on your own here. I'll put it up, keep the previous example up so you can compare. All right, if you do the nth root. You get the limit as n goes to infinity of 1/n. Which is 0. That's my L, it's less than 1. Convergent by the root test. All right, let's throw the fun one up. Limit as n goes to infinity. N over n plus 2 to the n. The summation. I got all excited. So this is not going to look like helpful for the ratio test. I'm not even sure where to begin with a divergent or p series or anything, but I have an nth power. So let's try the nth root. Let's do limit as n goes to infinity of the nth root of n over n plus 2 to the nth power. This gets us the limit as n goes to infinity of n over n plus 2. And if I multiply top and bottom by 1 over n, I get limit as n goes to infinity of 1 over 1 plus 2 to the n. As n goes to infinity, this fraction goes to 0, and this equals 1, which is my limit. And on the ratio test and root test, L equals 1 is bad. Not in a divergent sort of way, because that gives me an answer. This is inconclusive. So root test is out. If you took a peek at the ratio test, we would do n plus 1 over n plus 1 plus 2 to the n plus 1 over n to the n plus 2 to the n. And I ain't got nothing on that shit. I don't even know where to go from there. Nothing's gonna cancel. Nothing's nice and pretty. So this is a meh also. I tried 3 or 4 comparison tests trying to find shit to compare it to, do a limit comparison. You might try a lot of shit. Then I went, let's just go let u equal n plus 2. So that n equals u minus 2. And this changes our thing into u equals 3 to infinity of u minus 2 over u to the u minus 2. And you may be like, that doesn't give me a lot of ground, but now I can separate it. U equals 3 to infinity of 1 minus 2 over u. And u minus 2 as an exponent can be like that, can turn into a to the u over a squared. I'm going to do that here. I'm going to put u on top and then put 1 minus 2 to the u squared on bottom. Makes it a little bit easier to see. Helpful to know. 1 plus x over n to the nth power is e to the x. You might have learned it with just a 1 on top and it just being e, but if you put x in there on that, this holds true. And right now I haven't done any tests, but now I can hit this bastard with the divergence test. We're gonna do the limit as u goes to infinity. And that's gonna make this shit look like, I'm gonna rewrite it like this. Because it might help us see what we're looking for here. Give me a second to write all that shit down. This one was not easy. I'd be a dick to put something like this on a test. But that last test was pretty easy. Should I up my game, Dalton? Should I do something? No. He's like, I liked my good grade. Thank you very much. Right. All right, so this top part is following that is going to be e to the negative 2. This bottom part, as u goes to infinity, this goes to 0, and the bottom goes to 1. So this equals e to the negative 2. And what does that mean by the divergence test? It's not 0, which is good. Divergence test doesn't work for 0. So since it's not 0, our summation of n equals 1 to infinity of n over n plus 2 to the nth power diverges by the divergence test. I'll have you know, I initially even tried doing n plus 2 into n, and that gives you 1, like a long division. So n over n plus 2 turns into 1 minus 2 over n plus 2. But that wasn't even any fucking helpful. I tried a lot of fucking things. We only got a few minutes left. Let's make a list of things that are like good ideas to try and win. Because now we've got a lot of tests on our belts. It's like, what's a good idea? Some tests are easier than other tests. So you kind of want to like knock the easy ones out first, unless there's one that's really applicable. You want to need that page up longer? Okay. So, which test to use? And I'm going to tell you right now, experience is king here.
No.
Experience is going to speed this up so much. Do as many of these problems as you can. Like even better, once we do like alternating series, you can ignore. If you jump to like the chapter review at the end of the chapter, ignore anything that says Taylor series or Maclaurin series. You should be able, like it says, is it convergent or divergent? Just try them. Try as many as you can. I will put up some online to try. Ainsley will have some. She's making them. Andre, are you enjoying her SI session? Helpful. All right, so general guidelines. Things that you'll like, direct recognition will help. Does it look like a P series? Recognition. There we go. Spell it right, where it doesn't look sloppy. Is it like a P series? Geometric. Harmonic is kind of in the P series area. Harmonic. If you can't spot what it is right away, divergence test is often quick to check. Can be quick. It wasn't quick on that last one, but it can be quick, but can only show divergence. And while the next two are more work than some of the other ones, they are the way to do it in specific scenarios. And so like put them in a higher priority so you're not trying bullshit that isn't going to help you first. Ratio tests, again, good with factorials or exponentials. And when I mean exponentials, I mean like constant to an n power. You don't want to have a variable in there. That shit's going to make it miserable. And root test. Root test is only really good on variables within exponentials. Some form of like a to the n plus b to the n or some shit like that. Not a to the n, but an. There we go. I don't want an exponential in an exponential. That's even worse. After that, I don't know about you, but I think the limit comparison test was the easiest. Then integral test. And the comparison test is so fucking difficult to use. That should be your like last resort. Generally, if you can do the comparison test, you can probably do the limit comparison much easier. Go in this order. From top to bottom. Is usually the fastest. But it's not mandatory. If you spot something's going to be good for the ratio test right away, or the root test right away, why bother trying to do the divergence test? Jump straight to the ratio test, get rid of that fucking exponent, and see how it looks. And I got 2 minutes left. You guys got any questions? Not enough time to do some more, but
So with the comparison test, can you think of any where it wouldn't work, like the limit comparison test, but would work for the comparison test?
I will have to ponder on that. If I give you a quick answer, this is going to be a garbage answer. All right, I will see you guys on Monday. As a reminder, I am at the Mesa Center from 8 to 2 on Saturdays. If you're working on it, even if you're just working on your homework and don't even ask questions, having me there as a resource to ask is a beneficial thing. That's what a lot of students end up doing. Other than that, have a good weekend. Get the fuck out. The day is not right unless I tell you to get the fuck out.
Let's see you Monday.
Yep.
You'll have another chance to go to.